Okay, we're going to talk about S5K Arithmetic Series, and we're going to talk about finite series. So finite means it has an end. We're not going to add, and series is when you have a sequence of things and you add them together. Okay, and these are the formulas that we practiced with last time we talked. But before we're going to start talking about, we're going to do a warm-up. And the important thing to notice is on a recent test, when we did exponents, you saw something like this, 3e5 on the calculator. And if you wrote this on the test, on the IB test, they won't give you full credit. What this is saying is 3 times 10 to this power. So here's the solutions to our warm-up. If we're going to write something in scientific notation, you move over the decimal places till it's between the 1 and the 6, and then we have the power depending on how many decimal places we move. Okay. So if I have 1.2 e negative 1, this means 1.2 times 10 to the negative 1. If I have 5.04 e7, that means 5.04 times 10 to the 7th power. And this is just because we're moving the decimal place. Okay, let's talk about this last part of the warm-up, and then we'll go to working out the new handout. So you've got 2 points, and you want to find a perpendicular bisector. So the first thing we do is we find the slope between the 2 points, rise over run, change of the y values, divided by change of the x values, and we get our slope between these 2 points is 2. Then to find the perpendicular slope, because we want a perpendicular bisector, we take the reciprocal of 2 over 1, which is 1 over 2, and we change the sign. Next, we need to get the midpoint between the 2 points, and it's 3.5, 7, and using the 3.5 and the 7, we can plug that in for the x and the y, and then my slope of negative 1/2, and then we can solve for our b value. Multiply negative 1/2 times 3.5, and then add 1.75 on both sides, and we get our b value. Okay, you might want to hit pause and check your work. Okay, so now let's do some problems here. Okay, so I'm going to walk you through this one, and some of the problems we'll do, but this one I just want to walk through. We have the sum of finite arithmetic series is with the first term u subscript 1 and a common difference, and then the last term is u subscript n. So here I've got the first term and the last term. We would use this formula to find the sum of a whole bunch of numbers, and n is the number of terms. N is the number of terms. So you have to know how many things are we adding together. You use this formula if you know the very first term and the common difference between the different terms. And we still have n, which is the number of terms as well. Now, this formula is easier because it's much shorter, and if you know the first one and the last one, you can use this one. Sometimes you don't always know the last one. Like in this first example, it's 60, 50, 57, 54, ... In this case here, if you know the common difference in the first term, you can find the sum. So here they want you to calculate the sum of the first 20 terms. So I'm going to plug in 20 in place of n. And we know the very first term is 60. We can figure out the common difference, which is when you look between 60 and 57, if 57 minus 60, my common difference is negative 3. Okay, so I'm going to use this value there as the common difference. Okay, You know the common difference is negative if the next one is smaller than the previous one. Okay? So then you just plug this in and solve it. Now, the next one, let's do this together. Okay. So find the sum of the arithmetic series. So the first thing we do is we know that the first term, u subscript 1, is equal to negative 10. We know that the difference is equal to negative 6 minus negative 10. So my common difference is positive 4. And we know that the last term, u sub n, equals 90. So we don't know, so if I know the last term, I'm going to probably want to use this formula here, but we don't know how many terms we're adding up. So the very first thing we have to do is we have to find the n value in order to be able to use, you could use either of these formulas, but this one always seems easier. So let's solve for n. So in order to find the n value, I'm going to need to use the formula from last time we had class, which is u subscript n equals u sub 1 plus n minus 1 times d. Okay, so we know that d is 4, and we know our first term is negative 10, and we also know that our final term is 90. So now we can go ahead and solve this. So let's do. So 90 equals negative 10 plus n minus 1 times 4. Okay, so first thing I'm going to do is I'm going to add 10 on both sides. I get 100 equals n minus 1 times 4. And then I divide both sides by 4. And then I get 25 equals n minus 1. And then I add 1 on both sides, and I get n equals 26. Okay. So now that I know n is 26, I can use the easier formula, s subscript n equals 26 over 2. The first term is negative 10 plus, and the last term is 90. Okay, 26 divided by 2 is 13. Negative 10 plus 90 is 80. And I multiply those together, and we get 1040. Okay. Now, let's do this next question, 14b, a different way than some of us did in class in second and fourth period. Find the least number of terms that must be added to the series in order to get a sum greater than 100. So before getting started, here, let's u subscript 1 equals negative 10, and d is equal to negative 6 minus negative 10. So we've got a d value of 4. Okay, let's plug this equation into our calculator as it is. So we know the sum of the numbers is n over 2 times 2 u1 plus n minus 1 d. So we know d is 4 and u sub 1 is negative 10, so it's equal to n over 2 times 2 times negative 10 plus n minus 1 and then times 4. Okay. So, and that gives us the sum of the numbers. And what we want is that we want to obtain n value when this value is greater than 100. So let's type this equation as it is. We don't even need to simplify it or anything. Let's type it like it is. So I've got x divided by 2, parentheses, well, 2 times negative 10 is negative 20, plus parentheses, x minus 1, close parentheses, and then times 4, close parentheses. Okay. And now what I'm going to do now is do second graph. And that's going to give me a table. And when I get my table, remember we're going up by integers. The first time we're greater than 100 is when n equals 11 is the first time we are greater than 100. Okay, much easier way than what we did in second and fourth period today. Okay. Sigma notation. Okay, so what we've got here is we're going to talk about series some more. So when terms of a sequence can be added together, and when we add them together, this is called a series. We did some series just a few minutes ago. So u subscript 1 is my first term, u subscript n is the last one. And here I've got the summation symbol, and underneath it, it says I equals 1. I know it's hard to see that, but it says I equals 1. And over here on the top, it says n. So n is the number of terms that we're going to be adding together. Okay? And whatever this number is on the bottom, that's what we're going to start off with. So here if I've got a sequence 2, 4, 6, 8, 10, then the series, if I have S1, it's just the first not adding anything, it's just the first one. If I have S2, it's adding the first 2 together. S3 is adding the first 3 together. S4 is adding the first 4 together. Okay, so if I add the first 4 together, I get 2 plus 4 plus 6 plus 8. And it can be written like this. So what this is saying is we're going to replace I with 1. If I replace I with 1, I've got 2 times 1. Next term. So we go up as counting numbers. So the next number, I, is equal to 2. So we have 2 times 2. And then the next one we count up by 3. So I is now equal to 3. So 2 times 3. And then the last one, we make I equal to 4, and we have 2 times 4. And when we do summation, when we look at the summation, we stop at the last number that's up here in the top. And so then now we can add these together. We've got 2 plus 4 plus 6 plus 8. And now we can add those together, and that's equal to 20. Okay. Let's look at this first example together. Write the expression, we've got the sum from I equals 1 to 4. I equals 1 up to 4. And 2I plus 3 as a sum. So we're going to write as a sum of terms. So when I equals 1, we've got u sub 1 equals 2 times 1 plus 3, and that's going to give me 5. u subscript 2, we're going to have 2 times 2 plus 3, and that's going to give me 7. U subscript 3, U subscript 4. We're going to have 2 times 3 plus 3, 2 times 4 plus 3. 2 times 3 plus 3 is going to give me 9. 2 times 4 plus 3 is going to give me 11. Okay, so if we're going to write this as the sum of terms, we would say we have 5 plus 7 plus 9 plus 11. So whenever we're doing a series, we're adding the terms of the sequence together. And if I add all those together, we get 32. Okay. So one way of adding them together is simply to add them together. Another way I could have done it, because this is arithmetic, and since it is arithmetic, that means we could use one of these formulas from here, and I could simply use the first term and the last term. So I can say S sub n equals 4 over 2, because n is equal to 4. And the first term and the last term. Our first term is 5, our last term is 11. So 4 divided by 2 is 2. 5 plus 11 is 16. 2 times 16 is 32. What do you know? So you could either add the numbers together, or you could use the formula from the previous page. This would probably be easier if it was a lot of numbers to add, but it really doesn't matter how you do it. Okay, write the series using sigma notation. Okay, so the first thing I'm going to do is I'm going to draw the sigma symbol. And how many terms do we have? We have 1, 2, 3, 4, 5, and 6. So the top number is going to be 6. And notice to get to the next one, we keep adding 2, right? Plus 2 each time. We always start with I equals 1 on the bottom. Okay? And so since it's increasing by 2, I'm going to have 2i, because every time, whatever this number is times the I is going to tell us how much we're increasing by. In this example, we kept adding 2, right? Adding 2 each time. So here we're adding 2 each time. But notice we're starting with 1. So if I plugged in 1 in here for here, I'd have 2 times 1, which is 2. But this is 1 lower, so we have to do minus 1. Okay, and here is our series using sigma notation. Okay, if you don't believe me, you could check, right? So for u sub 1, I've got 2 times 1 minus 1, that's equal to 1. U sub 2 is 2 times 2 minus 1, that's equal to 3. U sub 3 is equal to 2 times 3 minus 1. That's equal to 5. And I think you can see that, look, we got it correct. Okay, so for the bottom 3 here, I'm going to show you my work, and then the rest of the worksheet we will do in a second video. Since all of these were arithmetic, I used the formula for finding the sum of an arithmetic series. So I found u sub 1 by plugging in 4 in for k, and then I found u sub 3 by plugging in 3 in for k. Here I plugged in 1 in for k here, and I plugged in 6 in for k. You may want to hit pause. Okay, the rest will be in the next video.